I'm Stanley Kroll with J.W. done. Job well done, and we manufacture the Orbitool deburring tools specifically for cross holes. So you can see our size range here. Tools can be used both manually and on a CNC application. We have a standard range of tools, standard lengths, and we also make custom length tools, custom pilot cutter for external features. We recently introduced our new micro tool here, which is a 1.1 millimeter 45 thousandths cutter. So I'll give the general concept of how the tool works. We've got this flexible shank made out of spring steel, a carbide burr, and a protective disc. The purpose of the disc is when we're preloading this tool against the wall, we don't damage the part in any way. Or in a manual setting, when we're operators using the tool by hand, we won't damage the workpiece in any way. We're only going to remove material at the intersection edge without damaging the wall. So we can use the tool both ways. I'll kind of demonstrate how the tool works in a CNC setting. So because of this flexible shank, that allows us to preload the tool against the hole. The protective disc prevents any damage to that wall. And then as the tool approaches the edge, it's going to selectively remove material only at this intersection edge. Now what's beautiful about it is you don't need to program the tool to follow any of these complex contours. You just make a simple helical interpolation path, essentially a thread milling routine. And as the tool reaches these edges, it will decide automatically when to protect this wall surface, when to cut this edge surface. It's an interruption in the cut that the tool is reacting to. But from a programming standpoint, you only need to tell the tool starting Z depth, finishing Z depth, interpolate between those 2 points. So here we can see that in practice. We have several configurations for single hemisphere, double hemisphere pilot tool for T's, elbows, or crosses. In a lathe setting, we have the part rotating, the tool's feeding in essentially like a boring bar and automatically adjusting to the surface. Same thought process for a T intersection. Again, the tool is constantly adjusting to this interrupted cut. Then we have the double hemisphere cutter. Same idea. Now we have an opposite edge that we need to deburr, but we can come in from one direction to do that. So this would be a cross-type intersection. Proceed further to the opposite edge and interpolate backwards. Now we have this interesting application for the pilot tool we mentioned earlier. Here we can do complex, irregular, three-dimensional elliptical contours on the outside of parts. Same concept, we're interpolating the tool, but that pilot shaft allows us to keep the tool safe and located on the hole so we don't fly away and damage the workpiece or damage the tool. Same tool comes in and deburrs the inside, so you have a one-tool solution for inside-outside deburring. Now if we want to see that in the real situation here, we've got a brass part. Tool comes in, instantly removes the burr. Same interpolation, don't need to program any special shapes, and the tool just selectively removes material from the intersection edge. Now a stainless part. In this case, we're doing it by hand. We just come in with a Dremel grinder, rotary grinder, start the tool up. Again, we're only selectively removing material at the intersection edge without making any damage to any other adjacent surfaces. So now coming to manual deburring like we mentioned. So simply put the tool in a grinder. In this case, we're using a simple Dremel grinder. 5 or 10,000 RPM. Flexible shank. Now, as we mentioned this protective ring earlier, I can place that disc right up on my fingernail without doing any damage. We're only removing material at the edge. So from a standpoint of a manual deburring operator, in this case we have a test piece where we can actually see all of the intersections. However, the operator doesn't have that luxury. They're having to deburr these complex inside edges while entering the part from the outside, and they don't always have an easy, accessible view of that intersection. So this makes life a lot easier for them because you can't damage the part. We're just deburring all this by feel. So if we want to see what's actually happening in there, I've got the tool rotating at around 15,000 RPM. I'm coming in from the outside of the part, place the disc on the wall, and then I just make a quick in and out motion, like a filing motion. Immediately we see the burr comes off. If I spend a little more time, I start to generate a radius. And as the operator, I'm not really deciding how much pressure to apply, where do I place the tool. I know that physically the tool can't remove material in any of the critical features, and it's only removing material at this intersection edge. It's very easy to use. Of course, in this case, I'm using a smaller tool, so it's taking a little bit longer. You can always use a larger tool and get a more aggressive result. So that's the whole setup. We make custom tools for any kind of maybe non-standard applications. Everything is stocked in California, almost always ships same day. And an important detail that we really like to stress to new customers, everything comes with a full performance guarantee. That's been our default policy for 20 years. It hasn't bankrupted us yet, so I think people aren't returning these too often. But just so folks know that it is risk-free to buy the tool, try it. We're very informal on replacements, returns if someone accidentally crashes the tool. We have, and we want to keep long-term customers for many years, so replacing a few tools in the beginning, we're really happy to do that. You can find us online, just Google Orbitool or our website, jwdone.com. An easy way to remember that is it stands for Job Well Done.